concept in SQL Server, that is deadlocks. So don't worry if the term sound intimidating, we will break it down step by step. Think of this presentation as your guide to navigating the traffic jams that can occur within your database. If you are ready to master deadlocks, hit that like button and right now and let's get started. To make this session as helpful as possible, I encourage you to actively participate if you have any question about deadlocks. Perhaps you have encountered them in your own work or something isn't clear. Please post them in the comment section below. We will address them throughout the presentation or at the end. Your insights and experience are incredibly valuable. So let's get it started. So understanding the deadlock in SQL Server. So first important topic is database concurrency. So before we can truly understand deadlock, we need to grasp the concept of database concurrency. Imagine a baseline online store where hundreds of customers and browser browse and buying products simultaneously. That's concurrency in action. A database like Server is designed to handle multiple user accessing and modifying data at the same time. To manage this and prevent uh, SOWs, SQL Server employ locking mechanism. Think of these locks as a traffic jams that traffic signals that control the flow of data access, ensuring that everyone gets their turn without crashing into each other. If you have ever dealt with a busy database, give this video a thumbs up. Second thing is impact of deadlocks. Now what happens when this carefully elaborate traffic flow breakdown? That's where deadlock comes in. Deadlocks can significantly degrade application performance. Imagine those traffic signals malfunctioning and causing cars to get stuck in an endless loop. And in a database, this is translated to query taking forever to execute, application becoming unresponsive, and users encountering frustrating error messages. This can lead to lost sales, unhappy customers, and a lot of headache for database administrators. Have you ever experienced a database freeze due to deadlock? Share your story in the comment box. Then understanding deadlocks. So this presentation is designed to equip you with the comprehensive understanding of deadlocks. We will start by providing a clear definition of what a deadlock actually is. Then we will uh, deep dive into the common causes that triggers this database deadlock. Next, we will explore the method SQL Server uses to detect deadlock. And finally, and most importantly, we will cover effective strategies for resolving deadlocks when they occur, and even better for preventing them from happening in the first place. By the end of this presentation, you will have a solid foundation for tackling deadlocks in your SQL Server environments. Make sure to stick around until the end for the best prevention tips. Then we discuss on causes of deadlocks. So basically, deadlock often arise from a specific way in which database operation are grouped and executed, which we call transaction handling. A transaction is a sequence of one or more database actions that are treated as a single unit. Think of it like a recipe. All the steps must be completed in order for the dish to be successful. If these steps aren't managed carefully, it can lead to situations where transactions are waiting for each other to release resources, leading to a deadlock. It's a similar to two chefs trying to use the same two pots at the same time, but each insisting on going first, blocking the others. If you have a database horror story related to the transactions, I would love to hear it in the comments. Then we move to next how we detect and read solutions. So fortunately, SQL Server isn't helpless in the face of deadlock. It has built-in mechanisms to automatically detect these situations. Once a deadlock is detected, SQL Server employs strategies to resolve essentially breaking up the traffic jam. We will explore these mechanisms in details. However, the best approach is always prevention. We will cover best practices and techniques to minimize the occurrence of deadlock in your database application. So don't forget to subscribe if you want to see more content like this. And finally, improving user experience things. The ultimate goal of understanding and managing deadlock is to provide a smooth and efficient experience for the users of your applications. By minimizing deadlocks, we can significantly improve application performance, reduce errors, and ensure that user can access and interact with data without frustrations. This translates to increased productivity, customer satisfaction, and overall business success. Think about your own experience with the slow or unresponsive applications. You know how important performance is. So, what's one database performance improvement you are most proud of? So, let me know. Now, let's deep dive into the technical aspects of deadlock within the SQL environment. To truly understand how deadlock occur and how to prevent them, we need to have a solid grasp of the fundamental concept of transactions and locking in SQL Server. So ready for the deep dive. So let's go with first topic. What is transaction? So basically in SQL Server, a transaction is a logical unit of work that consists of one or more SQL statements. It's like a package of database operation. Imagine you are transferring money from your one account to another account or your saving account. Okay, so this involved two operations. One, a transaction ensures that uh, two operations. So what are the two operations? One is deducting money, and next one is adding money into your second account. Okay, so it is deducted from here and added from here. Okay, so a transaction ensure that either both of these operations are completed successfully or neither of them is. If something goes wrong in the middle, the entire transaction is rolled back, meaning what database is returned to its original state. This is a crucial for maintaining data integrity. If this concept is new to you, rewatch this session and ask question below. So it involves the ACID properties. So transaction in a SQL Server adhere to set of property known as a ACID property. This is a fundamental concept in database management. ACID is acronym atomicity, consistency, isolation, and durability. So atomicity, it means that a transaction is an indivisible unit of work. It is an all or nothing propositions. Either all that operation within the transaction succeed or none of them. And consistency, This ensures that a transaction takes the database from one valid state to another valid state. Okay, like it preserves the integrity of the data. Next, isolation. So isolation, this property detects that transactions are isolated from each other. Concurrent transactions should not interfere with each other execution. And then durability. So this is a guarantee that once a transaction is committed, it means successfully completed. That changes to the data are permanent. Even in the event of the system failure, these ACID properties are the cornerstone of reliable database system. Do you know a real world example of each ACID property? Share your best one. Then our next topic is related to which help to more understanding of the transaction and locking. So locking mechanism. So to enforce the isolation property and prevent concurrent transaction from the corrupting data, SQL Server employs a locking mechanism. Think of it as a system of reservations. When a transaction need to access or modify a piece of data, it requests a lock on the data. If the lock is granted, other transaction may have to wait until the lock is released before they can access the same data. So this ensures that only one transaction can modify a specific piece of data at any time, at any given time, preventing conflicts. Ever had to wait for a database lock to release? You know the feeling. It is basically two types: shared and exclusive lock. Okay. So SQL Server utilize different type of locks, but the two primarily ones are shared and exclusive. So shared, these locks allow multiple transactions to read the same data concurrently. It's like a multiple people reading the same book in a library. They are not interfering with each other. And in exclusive locks, these locks are used when a transaction need to modify data. Only one transaction can hold an exclusively lock on a piece of data of any given time. Uh, so it's like only one person being able to write in that book at a time. This prevents the data corruption. Why do you think SQL Server need to both shared and exclusive locks? What would happen if we only had a one type? So let me know your thoughts. Then we discuss on the lock durations. So in lock duration, so the duration for which a lock is held is crucial. Generally, locks are held by a transaction until it reaches its conclusion. A transaction can end in one of two way. One is a committed, that is commit our code and roll back. So in commit operation, if all the operation within the transaction are successful, the transaction is committed and all the changes are permanently saved to database. And in rollback, if any operation within the transaction fails or if the transaction is explicitly cancelled, the transaction is rolled back and all the changes are undone. This ensures that the database remain in a consistent state. Even if error occur, understanding the lock duration is key to preventing problems. If you are finding this helpful, so please share it with a friend. And it is include the locking mechanism. While essential, can sometimes lead to a phenomenon called blocking. Okay, so this is when one transaction need to access data that is currently locked by another transaction. The first transaction is then forced to wait until the second transaction release the lock. Think of it So think of it as a waiting in line at a store. You are blocked from being served until the customer in front of you is finished. Blocking is a normal consequence of concurrency control, but the excessive blocking can significantly degrade the database performance. How do you usually identify excessive blocking in your system? What tools do you use? Okay, so now we understanding the SQL transaction and locking. Now that we have a solid understanding of transaction and locking in SQL Server, we are finally ready to define the central topic of our presentation, the deadlock. So get ready. This is where it all comes together. So a deadlock is a specific and particular problematic type of blocking scenario. It occurs when two or more transactions are stuck in a circular waiting pattern. Let's revisit our train analogy. Imagine two trains approaching an intersection. Train A need to cross the intersection, but it is blocked by train B, which is also on a track. At the same time, train B need to cross the intersection, but it is blocked by train A. Neither train A can move, and they stuck in a deadlocks. Similarly, in a database, a deadlock happen when transaction X, transaction A need a resource X, and that transaction 2 has, and the transaction B, and transaction B needs a resource that transaction A has. So they have both waiting for each other, creating a standstill. This is a crucial concept. If you are confused, pause and rewatch this part. Now we here another perhaps simpler analogy. Imagine two people, Alice and Bob, working on a project. Alice need two tools, a hammer and a screwdriver, and he needs the hammer first, then the screwdriver. And Bob also needs both tools, but he needs the screwdriver first, then the hammer. If Alice has a hammer and is waiting for Bob to give her his the screwdriver, and Bob has the screwdriver and is waiting for Alice to give him the hammer, they are in a deadlock. Neither can proceed. So, can you think of other real world situations that mirror this deadlock scenario? Post your best analogies in the comment box. Intervention requirement. It is a crucial to understand that deadlock are different from regular blocking. In regular blocking, the waiting transaction will eventually get the resource it need when the holding transaction completes. However, in a deadlock, the transactions are stuck in a permanent waiting loop and will never proceed unless an external force intervenes. SQL Server itself has to detect the deadlock and take action to break the cycle. This is why understanding detections is so vital. So how does SQL Server actually detect and resolve these deadlock situation? Let's uncover the secrets. So first is role of the deadlock monitor. So SQL Server has a built-in component called the deadlock monitor. This monitor consistently scans the system for a circular waiting pattern. It's like a traffic control system that is always on a lookout for potential jams. So it's constantly working behind the scene of keep your database running. Then victim selection process. So when the deadlock monitor detect a deadlock, it has to make a critical decision. It is choose one of the transaction involved in the deadlock to be the victim. The victim transaction is one of that will be rolled back, meaning its change will be done to break the deadlock cycle. SQL Server typically selects the transaction that is estimated to be the best costly to roll back, minimizing the overall impact on the system. It's like the traffic controller deciding which car to tow away to clear the jam as quickly as possible. So, do you think this is a fair approach? Share your opinion. Then it's going to roll back of victim transaction. So once the victim transaction is selected, SQL Server initiated a rollback of that transaction. This means that all the changes made by the transactions are undone and all the locks held by that transaction are released. This action break the circular waiting pattern and allow the other transaction to proceed. It's like a towing away the stalled car, allowing the other car to get moving again. So this rollback is why handling deadlock in your application code is so important. Then error 1205 notification. So the application that initiated the victim transaction receive a specific error message from the SQL server. Error number 1205. This error server serves as a notification that the transaction was involved in a deadlock and was terminated by SQL server. Application developer need to handle this error and appropriately often by retrying the transaction. If you have seen this error, so it's essential to differentiate between a deadlock and normal blocking. While both involve transaction waiting for resources, the key difference lies in the waiting pattern. In normal blocking, a transaction wait for another transaction to eventually release its lock. So the waiting transaction will proceed once the lock is released. In a deadlock, however, the transaction are locked in a circular wait and will never proceed without external intervention from SQL Server. All right. So we have established a solid understanding of what deadlocks are. Now let's turn our attention to the why, the common causes that trigger these deadlock in SQL Server. This is where we learn how prevent them. So one of the most frequent cause of deadlock is conflicting lock record. So this situation arises when two or more concurrent transactions access the same resources, such as table or row, but they access those resources in a different sequence. This difference in access order can lead to a circular waiting pattern where each transaction hold a lock on a resource that the other transaction need and vice versa. So for example, consider this scenario: transaction 1 first update a row in a table A and then update a row in a table B. So transaction 2 on the other hand first update a row in a table B and then attempt to update a row in a table A. If if transaction 1 require a lock on a row in a table A and then blocked trying to acquire a lock on the row in a table B. Because of transaction 2 already holds it and simultaneously transaction 2 acquire a lock on the row in a table B and is blocking trying to acquire a lock on the table A because of transaction A1 already hold it, a deadlock occur. So as you can see, like one sec, okay. So here you have seen that transaction one has locked the resource X, okay, and is waiting for the resource Y. And while transaction 2 has locked resource Y and is waiting for the resource X. So this so the most effective way to prevent deadlock caused by conflicting lock order is to ensure that all transactions that access the same resource do so in a consistent order. In our example, both transactions should either update table A first and then table B, or table B first, then table A. Establishing and adhering to coding standards that enforce consistent access order is crucial. So, thus, does this explanation of conflicting lock order make sense? Are there any question about it before we move on? Okay, so next thing, like a long running transaction that hold lock for an extended period, increasing likelihood of then large like operation that scan large amount of data can lead to longer transaction delay within delays such as waiting for user input or external processes can prolong and short keeping transactions short and touching fewer row to reduce deadlock. Then different aspects like poor aspects can force SQL Server to perform table or page scan, leading to more extensive locking. Covering reduce the needs for lookup, thus minimizing. Indexing foreign key critical for the preventing lock. So we have covered a lot of information about the causes and prevention of deadlocks. Now I want to open the floor for your question. This is your opportunity to clarify any point, ask for further example, or share your own experiences with deadlocks. So thank you so much for joining me today on this deep dive into SQL Server deadlocks. I truly hope you found this information valuable, that you now feel more confident in identifying and preventing these common database issues. Before you go, here are few things you can do to help out and learn more. Like this video, give it a big thumbs up. It's really helped the channel. Thanks again for watching, and I will catch you in the next one. Keep those SQL queries running smoothly.